this is our cloud security project implementation video. So our design represents a secure financial application hosted on AWS, where we've focused on both network security and monitoring and threat detection. The system is designed around a multi-tier architecture. We have a public tier, an application layer that scales automatically, and a private database layer that uses Amazon RDS and Elasticache. Flip worked on setting up the network components, including VPC configuration, subnets, routing, and secure connectivity between the tiers. This ensures that traffic is isolated and data flows securely between each layer. Because this was built in the AWS Academy sandbox, some services such as Guard Duty, Event Bridge, and custom IAM roles weren't available to us. To work around these restrictions, we simulated their functionality using CloudTrail insights, manual detections, and email alerts through SNS. This allowed us to still demonstrate how monitoring detection and alerting would operate in a real-world financial environment. Together, our implementation shows how network security and monitoring integrate to create a resilient and compliant cloud environment, ensuring financial transactions remain secure, auditable, and protected from threats. So my part focuses on monitoring and threat detection. This is a layer that protects the financial application's data and transactions from unauthorized access or misuse. So in a financial environment, visibility is everything. Every action must be recorded and traceable. So I used AWS services like CloudTrail, S3, buckets, CloudWatch, and SNS to make sure every login, change, or data movement is monitored and can be audited. So here I've set up AWS CloudTrail, which records every management or API event across our environment. In the context of a financial system, that means if someone modifies an account limit, accesses payment data, or deploys a new service, it's logged instantly. So these logs go directly to our secure S3 bucket for long-term storage, ensuring a full audit trail that a key requirement in a financial compliance. So all activity logs are stored here in an encrypted versioned S3 bucket that I've created. So this keeps our financial data traceable and tamper-proof. Even if a malicious actor tries to cover up their tracks, earlier versions of the logs remain preserved, which is essential for forensic analysis in a regulated industries. So I'm able to open up this trail here. So just press open, and all these events are recorded. So in AWS CloudTrail under event history, I can actually filter out for key activities like user logins. Here you can see who accessed the system, when and from which IP address as well. So in a real financial platform, this helps identify abnormal access, for example, an admin logging in from an unknown location before it becomes a fraud or a data breach of risk. So I can actually just click on to my earliest login here, and you can see my username and my time and my IP address is displayed. This part focuses on network visibility. So I enabled VPC flow logs to capture every accepted and rejected network connection in our environment. So each log entry records the source IP, destination IP, and whether the traffic was allowed or blocked. The kind of information like keeping a transaction record, but for network activity. So in a financial system, so this really helps detect suspicious patterns such as repeated rejected connections or unusual data transfers. And all logs are stored securely in our S3 bucket alongside CloudTrail. So it's giving us a full picture of both user actions and network behavior. To make our monitoring more proactive, I set up Amazon SNS for real-time alerts. This topic called sec alarms. So what it does is sends an email. So I've just popped in my email here to whenever a high-risk action occurs, like failed logins, new access keys, or policy changes. In a financial application, that means the security team is notified instantly if anything unusual happens that could affect customer data or transactions. Even in this sandbox, it shows how we'd automate quick detection and response in a real-time banking environment. And I did test it out by sending a test message and I received it. This is a message I sent out, and it's been received by my email. And so finally, this CloudWatch dashboard ties everything together in a single view. At the top, I added a text summary to clearly explain all our monitoring components connect. CloudTrail for activity tracking, S3 for secure log storage, SNS for alerts, and VPC flow logs for network visibility. It helps anyone, even non-technical staff, quickly understand the flow of how financial system is monitored end to end. And this line graph over here shows the number of event invocations, basically how often monitoring events occur, like logins, data access, or alert triggers. So currently there is a single dot that represents this, but it's limited in the sandbox activity. But in a real financial environment, you'd see regular spikes throughout the day as users and transactions take place. And here we can see the call count metric tracks how many notifications our SNS topic has sent, confirming our alert pipeline is active and responsive. So together, this dashboard gives financial security to teams as it's live and a visual snapshot of how system health is helping them detect issues early, confirm alerts, and maintain trust in their application security.
Hi, I'm Flynn Townsend, and in this demonstration, I'll be implementing the network security and protection component from our assessment. My section focuses on configuring a virtual private cloud, also known as a VPC, subnets, route tables, security groups, NACLs, NAT gateways, elastic load balancing as well, to secure the financial application environment. This layer establishes the preventative controls of our cloud security lifecycle and integrates with Sana's monitoring layer for detection and response. I will now create the VPC. So the VPC has been successfully created. This creates an isolated network, which is the foundation of our architecture. The CIDR block 10.0.0.0/16 gives us 65,000 IP addresses to divide between public and private subnets across multiple AZs or availability zones. This helps with segregating workloads and enforces PCI DSS and Privacy Act 1988 requirements for data isolation. These are the subnets I've created. So there are this A availability zone A subnets and availability zone B subnets as well. So the public ones, they're internet facing and they host services like load balancers, while private subnets hold more of the critical applications like the database tiers. Now that those have been created, we'll now head to route tables. Create route table. Name cloud free party. We'll select our VPC and then create it. We will edit its associations, so it's just with both public. Route tables define how traffic moves. Public routes through the internet gateway, private routes only through internal NAT gateways, avoiding accidental exposure of sensitive data. This is our security group here. They act as virtual firewalls at the instance level. We only allow HTTPS traffic for encrypted web requests and restrict all other inbound connections. This enforces least privilege and protects financial transactions from external intrusion. This will be the creation of our network ACL. our inbound rule, which will allow TCP 443 from the public subnets. We will also associate this with the private subnets. We will now create a NAT gateway. So the subnet associated with it is public subnet A. We've given it an elastic IP as well. Now we'll go back to the route tables. And then this is we'll edit the route now. We'll add it. And we'll route it to our gateway. The NAT gateway allows private subnets to access the internet for updates or patches, while still blocking unsolicited inbound traffic. This keeps our internal financial workloads isolated yet functional. In summary, this network configuration forms a preventive control layer of our security lifecycle, segmenting workloads, restricting access, and ensuring high availability. These network protections integrate with Sana's monitoring and detection services to deliver a defense in-depth architecture that secures our financial application in AWS. This is our VPC here. So you can see the subnets. We have our privates and public subnets A and B availability zones. Our route table with its associations, etc. Internet gateway, security groups, with rules, and ACL. Associated with the private subnets for this one as well. Thank you for watching, and I hope you enjoyed.
So, to summarize, our monitoring framework ensures that all financial operations are transparent, traceable, and protected. Even within the sandbox limits, we've built a complete detection and alerting pipeline using AWS CloudTrail, VPC flow logs, SNS alerts, and CloudWatch dashboards to maintain visibility, integrity, and trust in the financial security application.